the seedy side of society.
We call it the cloud because it sounds weightless, light, invisible, everywhere and nowhere. But every time you ask an AI a question, stream a video, or open a photo album, something very real wakes up somewhere on Earth. Lights turn on, power plants spin up, water moves to keep machines cool. And in 2025, researchers at Harvard Law School's Electricity Law Initiative warned that this invisible demand is quietly reshaping how entire regions pay for electricity. They weren't talking about the future. They were talking about what's already underway. Ari Pesco, director of the Electricity Law Initiative, put it plainly: facilities currently under development will use more electricity than large cities. That statement isn't dramatic, it's regulatory. Utilities across the United States are planning for massive new loads driven largely by data centers built to support cloud services and artificial intelligence. The issue isn't that the power doesn't exist. It's how the cost of building new infrastructure gets paid. Under long-standing utility rules, when new power plants or transmission lines are built, the cost is often spread across all ratepayers. That means households and small businesses can end up paying part of the bill for infrastructure built to serve a handful of massive computing facilities. Harvard researchers warned that this structure creates a quiet shift. Data centers receive discounted or specialized electricity contracts to attract investment, while the long-term cost of grid expansion is absorbed broadly, often without most residents realizing it. Nothing breaks. Nothing fails. But the margin disappears. This tension shows up most clearly in places already under stress. In the American West, utilities and regulators have publicly acknowledged that data centers are competing with residential and agricultural users for electricity and water in drought-prone regions. Permits were issued legally. Projects were approved carefully. But many of the assumptions behind those approvals, stable climate patterns, predictable demand, no longer hold. The data centers don't fluctuate. They don't slow down at night. They don't power down during heat waves. AI workloads increase demand precisely when cooling systems are already under strain. Utilities have noted that once these facilities come online, they become priority customers. Hospitals can curtail. Factories can pause. Residential demand rises and falls. Data centers cannot realistically shut down. The system doesn't collapse. It hardens around them. This isn't limited to one country. In India, water stress assessments have flagged data center growth near major metro areas as a rising concern. In Northern Europe, power authorities have openly debated whether grid capacity should serve local development or global computing demand. Even in cold climates, water-intensive cooling is still required during peak processing cycles. Different places. Same equation. Digital growth moves faster than physical infrastructure. And to be fair, the benefits are real. Data centers generate reliable tax revenue. They fund schools, roads, and public services. They attract fiber networks, grid upgrades, and highly skilled technical jobs. In some counties, they've become the financial backbone of local government. That's why towns keep saying yes. Not because they're reckless, because the upside is immediate and tangible. But the trade-off is permanent. Infrastructure built for residents now supports global platforms. Local systems quietly absorb worldwide demand. Risk shifts downward, while profit flows upward. Harvard Law researchers describe this as a structural issue, not a scandal. No single decision causes harm. It's the accumulation that matters. And as AI accelerates, the question becomes harder to avoid. If a small number of facilities drive most new electricity demand, should they still be treated like ordinary customers? If data centers use as much power as cities, should cost-sharing rules remain the same? These aren't philosophical questions. They're being debated right now in state utility commissions and regulatory hearings. The cloud doesn't float. It sits on land. It draws on water. It demands power. And in 2025, Harvard Law School made it clear that the way we regulate and pay for electricity in the age of hyperscale computing is approaching a reckoning. This isn't hype. It's policy colliding with an industry that wants growth yesterday. The cloud has an address, and now you know why that matters.
If something in this episode hits you, don't just scroll away. Like, subscribe, and tell us your take. We're new here, and you get to help build this from the ground up. We'll keep exploring the seedy side.